Okay, question 5 in exercise 21. Simplify this expression. Again, I'm going to go through the solution and give you one to have a go at the end. So if you're looking at this worked solution, have a go at the one that follows and the solutions at the end. So how do we proceed with this one? Well, the first thing to recognize is if I've got something like, in fractions, if I think of a fraction, 2 plus 3 over 5, I think you'd agree that ends up being 5 over 5, which is just 1. I could split this fraction into 2 over 5 plus 3 over 5, and again the answer would be 1. So if I've got in the denominator on top 2 plus 3 divided by 5, I can split each of the numbers on the top and divide each one by 5 and turn. And that's what I do here in this one. So I take the a squared b term on top in the denominator and divide that by a squared b squared. And then I take the second term plus a cubed b and divide that by a squared b squared as well. And now I use the law of indices, division going on, so dividing a squared by a squared is the same as a to the 2, minus 2 rather, which is a to the 0, and anything to the 0 is just 1, so that means the a has disappeared, and the other term, the b term, I've got b to the power 1 divided by b squared is the same as b to the 1 minus 2 is b to the minus 1 plus a cubed divided by a squared. 3 minus 2 is 1, so that leaves me just a to the power 1, or just a, and then b divided by b squared gives me b to the minus 1. Minus, from the laws of indices, anything to the power minus 1 is the same as 1 over x. Minus means the inverse. So I could write this b to the minus 1 as 1 over b plus a times b to the minus 1 is the same as, again, a times 1 over b, or a over b. So I could write it either way. 1 over b plus a over b. Because they're both over b, I can now go back to this first fraction idea that I was thinking of here. If they're both over 5, then I can actually add them and put it all over 5. So going backwards, I can now rewrite this as 1 plus a all over b, which is the answer in the textbook. So there's quite a lot of algebra in that. There's the idea of, if we look at this, the idea of a times 1 over b is the same as a divided by b. That's something that's worth remembering. And also a reminder that b to the minus 1 is the same as 1 over b. 1 over b there. Okay? Okay. Have a look at this one here. Very similar question. Simplify this expression. And the solution follows at the end. So pause this video clip and then have a go at the solution. Go at this and then the solution follows. Here is the answer. Separate out both parts of the denominator, divide each one by x squared, y squared. Then use the law of indices to get to this. X cubed divided by x squared, 3 divided minus 2 is 1, so that's just x. And the y, 2 minus 2 is nothing, so the y's cancel. And then the second term we get x to the minus 1, 1 minus 2 is minus 1, y to the 1, or just y. I can write this second term here as y over x, because x to the minus 1, remember, means 1 over x. And then note this last little step that you could do if you wanted. this answer here is perfectly okay. But if I did want a common denominator, and this is something that's sometimes used mathematically later on in engineering, if I wanted the denominator for both of these terms, the x and the y over x, to be the same, I have to make the denominator of this first term x. So what I do is I take the x, and looking at this part here, take the x and I times top and bottom by x. If I want to divide the bottom by x, so it's x underneath, as long as I times by x as well, that's fine. X times x gives x squared over x, which is this term here. Now they're both divided by x, so I can combine them. So that too is another way of writing the same thing. Equally valid, both equally valid answers, but there may be times when you want it in the second form. It's all about practicing these little rules of algebra.